Hi guys, my name is Sudhir. I have worked on the Kaggle IEEE fraud detection dataset for the IBM Capstone project. As you can see, these are the segments in the code. So this is the entire code for the fraud detection dataset. I have used Google Colab, which is an open source online Jupyter notebook by Google, which supports GPU and it has 12 GB RAM, which is free, which does not have any cap on the number of hours you use. So I have used this because 2 out of 3 algorithms need GPU for this project. So as you can see, I have used Keras, XGBoost and LGBM. I have used GPU for Keras and XGBoost, while LGBM is kind of a different setup, so I have not used the GPU for this algorithm. Coming to the dataset, so you can see the files here. So this is the entire Google Colab setup, which you can access it through your Chrome. So it takes your Google authentication and then saves the Python notebooks into the Google Drive. Here you can see the list of files. So I have created a folder called IEEE fraud detection, and here you have the zip files. So the Kaggle dataset comes in, as you know, like the test and train datasets. So there are 3 zip files: test identity, test transaction, train identity, and train transaction, and the sample submission zip file. So I have extracted all the CSV files. So this I have automated using the Kaggle API. This is the code for the Kaggle API. So where you need to give the API token, you can get it from your Kaggle account, username and key. From there I have downloaded the Kaggle the dataset, and then extracted all the zip files to the CSV. And then these are the packages that are used in this entire notebook. So this entire notebook is the end-to-end analytics or the data product. So I have not built anything separately as a data product or as an API, because this is a limited data set which does not update over time, and building a product or a API is not the kind of setup this dataset supports. So as you can see, the packages are straightforward. Like I have used SciPy, NumPy, Pandas for the data manipulation or data wrangling. I have used Seaborn, Plotly, and MATLAB Lib for the visualization, and the scikit-learn packages for pre-processing and for getting the train test split and other things. So other than this, I have used even the Keras packages and everything, so that we will see as we go on. I will just go through on the code on a high level, and then I explain you like what I have done and then why I have done in that way. And the other details are available in the Word document, which is explained in a thorough manner. I will go through this on a high level. So like I said, this is a read data function which reads the existing CSV files. The file names and everything are hard coded here, and the data names are also, and it returns 4 data frames. So I'm not reading the submission file here, I'm just reading the test and train datasets for identity and transaction level database. And like I said before, so this is the Kaggle function or the Kaggle lines of code for downloading the dataset automatically. And then you have the read data. Like I said, it returns 4 data frames, so I assign the 4 data frames here. And then I have different few custom functions. So one is the summary. So summary df is nothing but it takes a data frame as an input and then gives out you all the high level parameters of the data frame, like what are the column types and what is the shape, and then how many null values are there for each column and things like that. What is the first value, second value. So this helps us in identifying the data structure or the data spread in a short way. And then I have used this reduce memory function. So this is used from one of the Kaggle members. So they have posted it, and quite a lot of members have used this because the dataset takes up a lot of memory, the RAM. So because the most of the values in the particular column, like a float 64 or an int 64, there are lots of nulls, or each and every value does not need an int64 space. So going through the columns one by one and then seeing which requires that space and which doesn't require, and then um, compressing the data frame will help in saving more RAM memory, which will help in future manipulations like the data visualizations or the data model building. So this is one useful function which I have found. So this is on a high level, like the basic first few lines of code which will be used repeatedly in the next steps. Now the second comes the data visualization. So like I said, first reducing the memory. So here you can see what is the memory reduction per each data set or for each data frame after the memory usage function. And then, so like I have explained the summary df, so this is how it looks like, the name of the column, and then what is the type of that, and then how many missing values are there, how many unique values are there, what's the first value, and then the entropy and things like that. So we can include other values such as like mean, median, or what's the standard deviation and things like that. But I feel like this is the most important data. And the total data set size is around 500k, both terrain and test set. So this one I have felt like this is more important, and then give you an overview of like what's there in the data set. Coming to the data spread, so these are the few of the visualizations which I've done, which I will not be going through in detail. As you can see, the I have applied transaction amount logarithm to the transaction amount. So the data set is like self-explanatory. Once you go through the data set, you will understand like what are the columns available. So this is essentially a credit card transaction data set, which has all the data at each transaction level for each card and for each member, and then how much amount they have spent on the transaction. Since the transaction amount has a wide range, so I have applied the logarithmic transformation to that and see how it spreads. Like, so this is if it's a fraud, what is the distribution, and if it's not a fraud equal to 1 and fraud equal to 0, the distributions on higher level, like how the distribution looks like. And there are few other visualizations which support, like which helps us understand. So this is a highly imbalanced data set. Like you can see 96.5% are no fraud transactions, and then only 3.5% is a fraudulent transaction. So this is a very highly imbalanced data set. And going through the other functions, and so this is all these functions or the code is written to understand like what's the distribution of each and every column with relative to whether it's a fraud transaction or not. So this is all the code which I have written for the distributions, like the product code distribution, and then if whether it's a fraud or not, yes or no. This one I have used the Seaborn for few, and then Plotly for few. So Seaborn supports Boolean plot. This is what Boolean plot looks like. And then the summary of the few columns which are very important, like the card 4 and card 6 will give you like it's the string values. Like card 4 will give you whether it's a MasterCard or a Visa card and things like that, and the card 6 will tell you whether it's a credit or a debit card. So few metrics of few columns I've chosen based on the column names. So the column names are intuitive, and then they see that where the quartiles range and then how it's distributed. So I've deleted some of the plots because the Python notebook has become very huge with that all the plots and everything. So I've kept the plots only which are relevant and which are intuitive, and then which are helpful to understand the data set. So these are all the plots which will help understand the data set. So after the data visualization, the data cleaning part. So this is the most important, and then it took most of my time because like first you need to go through the entire data set and see like what needs to be there and what needs to be removed and things like that, and then you need to understand how you are removing it and why you are removing it. So first thing is the email domains. So there is some cleanup done in the email domains, like you have the same yahoo.com, yahoo.com.mx, .uk. So I've like these are some of the cleanups which are done like to bring all the values on the same page or the same level. to reduce the number of unique values. So if it says Gmail or gmail.com, it's Google. And then you have various varieties of yahoo.com especially, which have combined to Yahoo only. And then you have Hotmail, Outlook, MSN, all this comes under Microsoft. So I've put it under one bucket and things like that. So after that, you can see the number of unique values, the value counts for each variable. Like for Google, it's 57,000 the highest, and then comes the Microsoft. So the distribution is more or less the same for both training and test set. And then the similar thing has been done for the P email addresses. There are two email addresses, like P and R. So I've done the same thing for both. And then grouping the device OS. So again, the same thing, with different versions of the device OS, like Android 6.0, Android 7.0. So all these comes under only one version, which is Android, one type. So after all these manipulations, or after all these changes, like you can say again, the different value counts for each OS. So Windows being the most prominent one. And then device info as well, so from which mobile device they have done, or a laptop, or a PC, or an iPad, things like that. This is the cleanup for that. And then comes the browser. The browser also same thing, like removing all the version codes and just having the browser name. And then comes the ID33 transaction, wherein like I've split that into two things, like underscore with the underscore. So this is nothing but the device size, like the pixels, 1290 by 900, things like that. So I've split this column. So when it's combined, it's of no use, it's just a string. But when you divide it, it's a numerical value, and it might help in understanding like what are the mostly used devices for the fraudulent or the non-fraudulent transactions. And then comes the label encoding. So once all the cleanup is done, because we have reduced the number of unique values for each column, then the label encoding will be helpful for all the string columns. So I've taken all the string columns by object and data type, and then did the string encoding, label encoding. And then so this is for dropping all the columns which has most number of missing values. So if the missing values are high, then there is no point in imputing them, because the entire data set will change once you impute that. So I have taken the columns, the threshold as 80%. So any column which has more than 80% of null values, then I'm dropping those columns. So this code does that. So it calculates the null columns in both train and test, and then drops those columns from both train and test together, so that we are on the same page for predictions as well. And then the transaction amount, like I said, so the above one was just a visualization for the transaction amount. Now this is the transformation of the transaction amount into the logarithm, and replacing the original transaction amount with the log ones. And then this is a small function for the PCA. So the PCA I have done only for the columns which has more than which has null values, where there are missing values. So even after removing the 80% threshold columns, there are still some other missing values in the columns. So I have used PCA for that. So first I have imputed with the mean all the columns. So like I say, here you can see like wherever there are null values, I have imputed the column values with mean. And then once the imputation is done, I have applied the PCA on that. Also I have applied the min-max scaling to get all the values in the range 0 to 1. After this is done, the preprocessing is done both on the train and the test data set. Once this is done, I have applied, like I said, so I have applied the PCA on the training data set, PCA on the test data set. So after that, I have divided the data into train and validation sets. It's not the test set, it's the validation set, because the test set does not have the original values, fraud or not. So I have divided the train data into 80-20 ratio, like 80% is the training data and 20% is for the validation data. So after this, You can see the values like 470k odd are for the training, and then you have 120k for the validation set, and then the original test set has around 500k value. So more or less we can say the train and test set are exactly the same count. The few additional columns which I have done, so I have not done much feature engineering on this, because already the number of columns are very high. Like you can see, after all the feature, after all dropping all the columns with null values and everything, still you have 66 columns after PCA and everything. I've added only few things which I thought like would be helpful. One is the day of the week for the transaction, like when what is it done, like from Sunday to Saturday, like what was the day, and then transaction hour as well. So when was the transactions happening, either late night or early in the morning and things like that. So after that, the final step before going to modeling is the sorting the train data set with the transaction date, so that the training happens on a serial, on the increasing time basis. And then after that, I have dropped the train data and the transaction ID, transaction date and transaction ID. After all the data manipulation and the data feature engineering, everything is done, now comes the modeling part. We'll go to the KRS model first. So I have not done much on this, so whatever was given in the IBM videos given by the professor, so I have used the same code and the same options and everything. So here you can see I have used an RNN, it's a sequential one with dense layer, 2 dense layers, and after that like total 5 dense layers. And the binary cross entropy is the loss function, and then the metrics I'm using here is the accuracy. The optimizer is the HGD one because it's the most prominently used one. So this is the total setting for the Keras backend. So once this is done, I have done the fit with the batch size 32 and approx 15. So you can see all the runs here. So this is all run already. So you can just see the output here, how it's what is there and all. So after the training is done, the test set is the scoring is 96.49%, and the predictions I have saved it in the CSV file. CLF.predict test batch size is 128, and then you can see I have read the submission function here, submission file here, and then I have put the fraud predictions into this dataset, and then written into the CSV file. And after that, I also have saved the Keras model as an H5, so that we can use the same model if you want to train more on this, which is like a transfer learning, or if you want to predict a new set of data using the same model, that also we can use this one. So this is about the Keras. I'll quickly go through the XGBoost and the LGPM. So like I said, the Keras and the XGBoost both run on the GPU. So these are the specifications that are found in the internet, like which are optimum for the data according to the data set. And then here also the optimization function is the AOC. So it checks the AOC score, and then based on that it calculates. So this here also I have taken the submission file and then updated the CSV sample submission. And then I have pickled the model using gzip and pickle.dump. So this is also saved into the local machine, which can be used in future purposes. Next comes the LGBM model. So LGBM model is kind of a new algorithm which is based on the GBM memory, but it's in a different way. So this is performing very good when compared to the deep learning model Keras and the XGBoost. For the XGBoost model, we need to do a hyperparameter tuning, but that I have not included here. because that's still work in progress, so it's not giving optimum results unless you put the correct parameters. These are the parameters for the LGBM, like I said again. So these are based on the data set, and then how we choose is based on the. I've gone through the Google code and the documentation, official documentation for LGBM, and then set these values. I've tried to use the GPU here, but since I don't have the admin rights here, and then I don't know whether the CUDA is installed or not, so I've not used GPU for the LGBM. So this is the run on the CPU only. So here it's NSplits is 5, and then the same data set, and then I have used AUC here for the validation and this one. Here the LGBM, one important thing is like it will give you the features also, the top important features which are used for the model training. Here you can see the card one and the PCA values and the transaction amount and other PCA values like the transaction day of the week, transaction hour. So these are of high importance. And then the choosing the best iteration out of the LGBM, that's what makes it special. Like it out of the many iterations it has gone through, it will give you to you will be able to select the best iteration here. And then I have used that to read the submission file and then predict the output. And then even I have pickled this file model as well to the local folder with using gzip. So this is more or less about the entire project of IEEE fraud detection from Kaggle. Thank you. To add to the existing code, I've created a dashboard using Plotly Dash. So Dash is an open source package from Plotly.js, which is similar to D3.js. So it's running on 8050 port. I've already shared the code for the Dash. Going to the website, there are two tabs like training and testing. If you click on the tab, it will show you a high level summary of what the data set is and then how the distribution is. So this is the numeric data distribution, and then what are the quantiles and the minimum and max and then mean and standard deviations, and these are the categorical values. These are some of the charts which I have included using Plotly, like the fraud non-fraud distribution, and then by different categorical features. These are some of the images from other packages like Matplotlib and Seaborn. Same would apply for testing tab as well. That's it on the dashboard part. Thank you.